All right, welcome everybody. Today, Clemens and I are going to be talking to you about cloud events, in particular the status of the cloud events project and where we're headed in the future. Hopefully we'll have time for questions at the end. So let's go ahead and jump right into it because we have a lot of material here. So first of all, quick agenda. Give you a quick update on where we are with the cloud events project and then very quickly jump over to some of the new work that we're doing here. So let's start with cloud events itself. So I'm not going to go into too deep detail here, but for those of you who don't know what Cloud Events is, it is a specification for defining common metadata for events and where that metadata appears in the messages that are transporting those events. Now, it seems very simple at a very high level, and it is, but we're really doing this mainly to aid in the delivery of events from point A to point B. This is not about defining yet another common event format or anything like that. I'll show you an example in a minute. This is simply about aiding in the delivery of events across middleware to its final destination. And most importantly, to enable people to do that without having to understand or parse the business logic of the event itself. Okay, so let's jump into a quick example to show you what that actually means. So let's say you have this event flowing over HTTP, right? Nothing in here too special, looks like a normal HTTP event. In order to turn this into a cloud event though, you add a couple of bit of extra metadata as HTTP headers in this case, and you can see just 4 little bits of metadata. And these are the only 4 that are required. The spec version, the cloud event spec version that is, the type of the event. So this tells you, for example, whether it's a create versus a delete type of event, where the event came from, what is the entity that was sending out the events, and then just some unique identifier. Okay. Now, obviously, look at that. It doesn't seem too exciting, but with that basic information, middleware can now route the message appropriately to make its way to its final destination, much in the same way you can actually see the HTTP headers doing that for the HTTP layer. Okay. And as I said, it's actually a very, very simple concept, but with that one little extra bit of information, middleware can now be eventing agnostic in terms of understanding the business logic. All they need to do is look for these common bits of metadata to route the event appropriately. Okay, very, very simple concept, but we're hearing lots of kudos from the community how this is making life easier because they no longer have to have specialized middleware for every type of event that flows through the system. Now, obviously, the final destination still needs to understand the event and the business logic to get its job done. But in terms of routing, this is the type of information that should be the bare minimum that people need to get their job done. Now, this example right here is what we call the binary format. Just adds a couple of HTTP headers, so your original message should remain basically unchanged. However, there are some people who wanted to have everything encapsulated inside the body. As for those particular cases, we actually define some syntax, for example, here in this JSON version, where we actually put everything into the body itself. But you can see it's the exact same data, right? You got the same 4 pieces of metadata, the content type of the data attribute, and the data attribute can hold the business logic, right? All the exact same information. Now, the content type of the HTTP header level obviously tells you that this is not just a normal JSON object or JSON payload, but it's a cloud event JSON payload. So that's how you can distinguish between the left-hand side, which is just application JSON, which is binary, and the structure side on the right-hand side, which is application/JSON or slash cloud event/JSON. Okay. So that's it at a very, very high level. Very simple thing, but we're getting lots of kudos about it, and lots of different people are picking it up across the industry. In terms of deliverables, this is the big news. We did go 1.0 fairly recently, so yay for that. And in terms of what we're actually producing, we have different specifications, not just the spec itself in terms of what the metadata is, but also how it appears in different formats, right? HTTP versus AMQP, that kind of stuff. Different encoding, right? I showed you the JSON, we also have Avro, and we also included a primer because there are a lot of technical decisions we made which don't really go into a spec itself, but we wanted people to understand why we made the decisions we made. So we created a primer as a background for people to understand some of the decisions we made and some of the design choices. Now, we do have some SDKs out there with a whole bunch of different languages, which you can see on the screen. Most of them are very, very active. In particular, the Go one and the C# and JavaScript and Java are very, very active. So please take a look at those when you get a chance. They're not that complicated. They're just mainly there helping you to serialize and deserialize these cloud events. Okay. So what's next for us? Obviously, more customer feedback. Now that it's out there, people tend to wait until things go 1.0 before they adopt it. So we're hoping to get more feedback from there. And we have been getting a lot of kudos so far, as I said. And however, beyond that, though, we're not just sitting back and waiting for that feedback. We are starting to look at what additional pain points the community has relative to the eventing space, not just for functions and servers and stuff like that, but in general, what are the pain points people are experiencing? Okay. And with that, let me then turn it over to Clemens, who's going to talk about some of these additional work items we're doing, specifically aimed at addressing some of those pain points.
Yes. And for those, we have two areas, discovery and the subscription APIs and the schema registry, which I'm going to discuss both. What's important to note is that in CloudEvents, we talk in the CloudEvent core specification where we, or set of specifications where we have transport bindings and encodings. We're really mostly focusing on delivery of CloudEvents. But that's just the end of the story, because before you can deliver a cloud event, you obviously have to indicate your interest in that cloud event. And then you also have to find who's actually publishing that cloud event. And that's the thing that we're tackling in this next round of specifications that we're working on. So the first element is how to discover which cloud events are available for subscription. Today, what you do is you read documentation, typically. So you go on the website, documentation website, and you find a list of events that's being raised. And for that to be automatable, we need to have a way to learn about services, be able to filter those services based on some criteria, and then learn about which services expose with which events, or reversely, allow a knowing about some events that you can handle, and then learning which services in your vicinity or some other criteria are supporting those events. So questions that we have is who produces events, which events are produced, which subscription options are available, how do I get the events delivered to me, and then where and how do I subscribe. Next. So what we've done here is we're not very prescriptive, and that's a theme in CloudEvents overall, is the principle that we're not prescriptive about how you should implement your service. And there may be some reference implementations of these things down the road, but ultimately what we're defining here are interfaces. So we are defining abstractly a data model that defines, for instance, here in this way, what a service is for discovery, and also defines, and that's obviously leaning on the core specification that we have for CloudEvents, that defines what a type is. And then based on this, we then define a HTTP and a gRPC API that we have today in the drafts, and we might have further protocols such as AMQP later. So we define an interface, and when you implement that interface, then you have a discovery service. The notion of service, that's the concept inside of the discovery service, is very simple. It's just some software entity that emits events, so that gets registered in the discovery service. That service, since it emits events, maintains a subscription endpoint, and really what the service description here does, it just enumerates the types of events that are available for subscription with some further information. And then we have a type collection. The type collection is really for the reverse lookup of which services are available. And this is an interface that can be implemented in one place or can be implemented in multiple places. It's obviously also allowed to federate those discovery services. So you can really create a catalog of services, and you can make that catalog available everywhere with the same interface. You can imagine having a local cache that exists somewhere near your consumers and makes those available. And of course, the discovery mechanism will also allow the catalog to be adjusted to the circumstances that you have near your endpoint. So if it's required to subscribe via a different subscription manager, we're going to get to that in a second, to be able to deliver those events into your respective endpoint that you have, then that sort of translation can also be done in that discovery model. It's not expressed explicitly, because the interface is kept very simple, but the flexibility is there to allow this. Next. Once you have discovered which events are available, then you want to be able to subscribe to them. And again, today in CloudEvents, in the base CloudEvents spec, that's something that we've made a matter of out-of-band agreements. Some protocols, for instance, AMQP or MQTT or Kafka, already have built-in facilities to subscribe. So if you are designating a subscription manager that is a queue, or sorry, or a topic inside of a message broker, then it's implied effectively what that subscription protocol is. If you're using AMQP, for instance. But for HTTP, for instance, HTTP doesn't have a built-in subscription notion. So even though those subscription services are fairly common, or these subscription patterns are fairly common with webhooks, it's something that we have not seen being sufficiently standardized. So we had to find a way to go and create a specification that acknowledges the existence of these existing protocols like AMQP and MQTT, which have built-in subscription notions. And then at the same time, add a ability for protocols that don't have that, like HTTP, to also allow you to do a subscription gesture. And that's why we wrote the subscription API. The subscription API specification acknowledges those or enumerates the subscription facilities that exist in those other protocols supported by CloudEvents, and then explicitly introduces an API which can then be implemented using HTTP, or can be implemented using gRPC, or implemented any other protocol that specifically needs this to go and effectively manage subscriptions. And for that, we've introduced the notion of a subscription manager. Next. So the subscription manager is the one that implements the subscription API. And the subscription manager might act on behalf of itself. So it may really be the entity that emits those events, but it also may act on behalf of others. So you have that very often in larger setups where we have very, very many producers, and those many producers produce events into a middleware of sorts. And then if you are interested in events from a particular publisher or a group of publishers, then you are subscribing on that middleware on behalf of those producers. So one of the obvious examples here is, for instance, IoT, where you have sometimes thousands or hundreds of thousands of devices switching into a cloud endpoint. And if you're interested in specific events emitted by those devices, you would not subscribe to every single device, but you really would go to the subscription manager, which has the pool of events, to go and pull out the events that you need. For the subscription manager, as said, we're enumerating the existing mechanisms of existing protocols that we have defined this HTTP API to help with the cases where, or API and API abstraction to help with the cases where that is not available. We also have two delivery styles, and that is the push delivery and the pull delivery. So we're distinguishing between those two, where typically for CloudEvents, as we've defined it today, mostly the delivery is assumed to be push, which means the producer or the subscription manager acting on its behalf pushes those events by establishing a connection and sending the event along. Or this can also now, the definition here allows for pull delivery style, where you are effectively having the subscription manager maintaining a queue, for instance, on behalf of the producer. So both of those things are possible. Next. So those were effectively complementing the mechanisms that we have today in CloudEvents by closing the loop. We have delivery, something that's defined now, and now we have discovery and subscription that we're adding to it. A really important further element is the schema registry. Next. Every cloud event can carry a payload with event details, mostly in the form of structured data. Structured data, if you're sending it to another party, will require often for that other party to be able to validate whether that structured data is correct, based on some syntactic rules that can be expressed in a schema. And then there's often also a need for serialization, where you want to have an in-memory data structure to be serialized out using an efficient format. And those efficient formats often leave the structural metadata out. Like you're familiar with what JSON looks like. JSON is very repetitive and puts all the metadata elements and the type information kind of into the document itself. And there's a number of far more efficient serialization formats which don't do that, and they keep that information outside in schema documents. But then once you use that, the question is, where do you put those documents? So the goal of the schema registry is to allow you to store these documents and access those documents in a consistent way, so that you can go and build software elements, a serializer and a validator, that can then lean on those schemas and on hints that come with the event, and then can go and deserialize that structured data or serialize that structured data. And the goal is for that to be project neutral and vendor neutral, so that that works for CloudEvents, but that also works for other messaging and eventing infrastructures, because we often see that things get born as CloudEvents, but then get forwarded through other messaging infrastructures as well. And so we don't want to constrain this to the case of CloudEvents. And CloudEvents also is just using in the binary format, is just using a message payload like any other message or eventing use case would. So it simply doesn't make sense to constrain the registry just to CloudEvents use cases. Next. So that's one of the principles that we have, is at the bottom what I just said, that it should be scenario neutral. It should also be protocol neutral. So the registry data model is abstractly defined, and the HTTP binding that we have, so setting and receiving message schemas via HTTP, that's well defined right now with an open API document. But the registry per se, the data model is abstractly defined, and it allows for protocol bindings, and we certainly anticipate to have an AMQP binding for this, and hopefully more bindings. That somewhat depends, because it's a request response model, depends on the capabilities of the respective protocols, but gRPC is also certainly in the cards. And of course, we want to keep this as simple as possible. We don't want to turn this into a massive metadata store with super powerful capabilities. So there's no goal here to rival the capabilities of Apache Atlas or something like this, but really is like, you should be able to implement this registry API over a plain file system or a Cloud Blob store, and it's just there to store those schemas and manage those schemas in the simplest possible way, while providing the core capabilities we need. Next. So this complements the event delivery model that I just talked about, by allowing the producers to manage and validate, or someone on behalf of the producers to manage and validate the schemas, and then really think about the data field in the cloud event and how that can be serialized and deserialized. And that model here, what's in the green, works for CloudEvents as we have defined it, but also works for other eventing scenarios as well. So this is kind of for you to get visualized what this is about. It's really for serialization, deserialization, or validation on either side, and it really pertains to the data element that sits inside of the cloud event. Next. Finally, the structure of the schema registry. We've structured this such that there is a notion of groups. They can group, so a schema registry is split up into groups. Those groups can be by application or by some other criteria. They're really also there as an anchor for access control. So you may want to go and limit access to schemas by groups, because they may carry important secrets. So you don't want to make them accessible to everybody. And then within that, you have schemas, which really are containers for sets of schema documents that represent the same data structures. And then, of course, those schemas evolve, and so the documents are really the leaves of this. We have various schema versions, starting with schema version 1, where if you're adding fields or if you're making fields obsolete but you don't remove them, then you're still within the same backwards compatible schema of generations, line of generations, and that's where you simply add schema versions. We have some rules for how to add and manage those schemas. So it's a very simple structure to manage effectively schema documents. Next. And that's where we are. We will take some live questions at the end of this presentation, following now. If you want to learn more about CloudEvents, go to CloudEvents.io. Our specification repository is on GitHub on CloudEvents/spec. That's where you also will find the latest versions of all of those things. And we also have weekly calls Thursdays at 12 p.m. Eastern time, US, or 1800 Central European time. And in the repo is also the dial-in information. And then you can also follow Doug and myself on Twitter or send us email if you have any further questions.
All right, cool. Thank you, Clemens. All right, thank you, everybody. We'll stop the recording here and take questions live. Thank you all.